All right. Good evening, everyone. Welcome to the 10th class in this series. Today, we are going to be discussing AI image tools and application. This is going to be version one because today we believe in trashing out the theoretical aspect of it before just jumping into using the tools. So, today we are going to be looking at images, right? Again, our objective is to realize what AI can do and what we can make AI do. Our classes usually on Tuesdays and Thursdays. So let's talk about images, right? The computer recognizing different elements, image, text, audio, video, and all that. These are the kind of data you could use your system to, ingest, process, store, and what? Retrieve. Now, when we talk about images, right, we talk about pixel. I talked about picture is like represented in small, small units. For instance, if you divide the human body, you're going to land in the cell. The cell is the smallest unit, right? In terms of elements, you talk of atom. In terms of substance, you talk of molecules. So the way we define the smallest units of a particle as an atom, that's how pixel represents the smallest units of a picture. So what we're talking about here is that the computer system does not really know red, green, or blue or something, right? So let us go back to our primary colors. So we have red, we have green, and blue. So the way we standardize a representation of color in the computer world is coded into what we call binary. Binary can only be represented in one and what zero. So an example is before you here. You have a hot pink. So hot pink is not a primary color. What we are saying is that every color in the world can be generated by combination of these primary colors. So how do you get hot pink? Like I said, hot pink is a combination of 255 of red, 105 of what uh, green, and blue is 100 and what 180. So you might not understand this. I'm going to pull up a slide to just explain what I mean by these numbers because it's going to be confusing a lot of people, right? So I am going to pull up the numbers now. Then, sorry, the slide, and then I'm going to explain exactly what I mean. Okay, so this is decimal base 10, right? We all did this in second primary school. Like you have units 10, 100, thousand, tens of thousands, hundreds of thousands, a million, and it goes on and on and on. Let's look at the unit, the first box from the right hand side. What this shows is that before moving from the first box to the second one, if you multiply by 10, you get 1 times 10, that's 10. If you multiply by 10 again, that's 10 times 10, that's 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000, and then a million. So the number that are written beneath the boxes shows the possibilities of all the numbers that can occupy a particular box. So what it means is that from 0 to 9, nothing else, right? So, but depending on the position of the number, okay, you can derive the value of the number. So if 1 is in the first one, it means 1 unit. 9 is 9 units. You cannot have 10 as 2 digits in that one. If it is 10, you put it as 1 in the next unit, which is 1 and then 0 in the other one. Like I said, if 2 occupies that second position, it is no longer just ordinary 2, but it is 20. It has the value 20. So if you have like 7 in the third one, it has the value 700, not just 7. So if you have something like 725, it means 700 plus 20 plus 5. So having said that, this is all we know, like this is normal. Now let's go to base 2, right? So base 2, this is called binary, okay? The same way, you start from the unit 1, but in base 2, you're going to be multiplying by 2 and not by 10. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on and so forth. Now, the numbers written beneath the boxes just shows the possibility. You can only have 0 and 1, okay? So because of this possibility, you can look at it as yes and no, on or off, okay, true or false or something like that. So you can't have any other thing inside that box, only ones and zero. And this is how the computer, kind of processes information. So like I said, if you put 1, it means it is on. Just take it like, just let's draw that analogy. If it is 0, it means it's off. So now, if we have one bulb, assuming in your room there's only one bulb in your room, okay, what it means in this particular slide is that from 2 to 64 does not exist. Okay, so that particular is what is in your room. So it can either come on or off, only one bulb in your room. Okay. Now, if you have 2 bulbs in your room, it means the box from 4, 8, 16, 32, 64 does not exist, right? Now, when you had only one bulb in your room, there are only 2 possibilities. Now that you have 2 bulbs in your room, there are 4 possibilities. Okay, there can either be 0, 0 inside that box, or 0, 0 means that both of the bulbs are off. 1, 1 means that both of the bulbs are what? On. Then you can have 1, 0, meaning that one bulb is on, the other one is off, or 0, 1. The first one now is now off, the second one is now. So you can see just having 2, okay, has increased the possibility of information. This on and off is like, call it an arrangement. So we have moved from only 2 arrangements when it was only one bulb to 4 arrangements when it is 2 bulbs. If we move to 4 bulbs, we are going to have 9 arrangements. I don't want to go on that because this just is not really what we want to do in the class. So what we are saying is that the more the boxes, the more the information that is represented. Okay, so this is how the computer represents every single information in the world, because there's no information that it cannot represent with combination of ones and zeros. So if we move on now, you're going to see something. Assuming I want to type code on my keyboard, this is text-based now. Okay, on my keyboard, the ASCII value for C is 67. I'm going to show you the ASCII table. The ASCII value of O is 79. The ASCII value of D is 68, and the ASCII value of E is 69. So these 67, 79, 78, 69 are all decimal representation. So if you want to translate them to binary, okay, this is what it means. Let's take C. So whenever you touch your C, capital C, by the way, because capital C has another representation, even the small letter C, lowercase c, has another number. So, but I'm going to show you that in a moment. Okay. So why are you seeing 100011 in the first one? Now the question is, right, how many combination of those numbers you see there? Look at the boxes: 1, 2, 4, 8, 6, 32, and 16. How many combination of it will give you a total of 67? And the answer is what? 64, 2, and 1. So you could see, so you need to put on 64, and you need to put on 2, and you need to put on 1. So when I say put on, it means you represent them with 1, 1. Every other thing is 0. In the same way, 79. How can we get 79 with the combination that we have seen there? So for us to get 79, we have to add 64 plus 8 plus 4 plus 2 plus 1. That's how you can get the capital letter O, 79. So that's why you are seeing 1001111. So how do we get 68? You see the combination there and all. So having said that, okay, this is what I just wanted to show you, right? So you could see the red that you saw in the slide I showed you is 111111, meaning these boxes represent bits. So all of them are on 111111. So you can see that is red. Okay. Now the other one you see is green. Okay. The green, okay, you need to what? Green is 105 or something. I'll go back to that the slide. So you see that for you to get it is going to be 1, you off 2, you off 4, you off 8, and everything. So I just want to relate this, okay, to the other one. So can anybody guess, what the blue? I want people to give me an answer, just a short exercise here. The blue is 180. So just for us to do like a hands-on, what do people think this blue will be in terms of binary? So again, it's 180. So what combination of these can give us 180? I want to see those that can do it in this session. Okay, let's just drop it. What do you think? How can I get 180 from this? Any trial? It's just additional. Okay, somebody said 128, 32, 16, and 2. That's virtue is on. Okay, thank you. I think there's a hand up. Imola, your hand is still up. Do you want to say anything? Or is it the first one? All right. Do we agree with virtue? Virtue says it's 128, 32, 16, and 2. Do we agree with her? Any other person, any other trial? Okay, okay, okay. So that's the consensus. So thank you very much. It means that you are following me. So that will give you the pink. Okay. So what we are going to do is 128. So let's do it practically here. 128. So 128. We put it what on? Right. Good. The next one is what? Somebody should speak because I'm not longer seeing that the message side. So somebody who can see the message should just read it out for me, please. I have 120. What's the next one?
32, sir.
32. Okay. So 32. Okay. What's the next one? 128, 32. What and what?
16.
16.
16 and 4.
And what? And
4.
4. Okay. Thank you. So this is going to be what? 1, 1, 0, 1, 1, 0, 1, 0, 0. So this is exactly what I'm trying to convey. So having understood this, I will now bring up the other slide and continue from there. So all right, thank you very much for participating. Now I'm going to, so that from here now, it is going to like make sense, right? So that we understand, because some people saw this slide and will be like, what's going on here? So now, having done that, what we are saying now is that if you have this, okay, this is hot pink, right? By the time you combine 101 of red, 105 of green, and then 108, and you send it to the central processing unit, it knows that that particular value is hot pink because you are mixing the color. You can get every other color from here. So you can see the arrangement. Now let's continue. Now, this is exactly how images are formed, because the pixel you are talking about, right, is just a dot. That's where you combine all of them, and I mentioned before now that pixel can take as much as 16 million, as in one of the dots can take as much as 16,777,216. Okay. So if you have, okay. So is this okay? Now I'm seeing some internet signal. Can I be heard? Why is it appearing on my screen? Am I still
Yeah,
being
loud and
visible?
yeah,
All right.
loud and clear.
Thank you. All right, so it might be just a one-off. So what you're seeing here now is, different pixel and everything. So let's just take an iPhone. People are crazy about iPhone and all that. You know, so let's take that for a moment. You know that when they talk that something of resolution is, so and so resolution, like a camera is so and so resolution. What it actually means is that those boxes, this by this, is like the matrix of the number of boxes. So if you take like an iPhone, for instance, okay, iPhone 11, and they tell you that the resolution is okay. So what we are talking about now is, so we have this, okay. If we actually arrange it in a particular way, right? While you are looking at a very beautiful picture, um, the computer is not actually seeing this picture. It's a bunch of ones and zeros, arranged in certain pixel and all that. So I was saying that iPhone, this is what I was saying before. If you look at the right hand side, if they say an iPhone 11 has a display resolution of 170, sorry, 1792 by 824, it means that if you multiply it, you see that you have 1,400,000 pixels. Okay, so that's a lot of pixels. That's what it means. So if you look at it now, instead of random colors, each of these dots can be represented. So most of you, let me quite relate it to what we already know. When you hear LED, okay, it means light emitting diode. If you notice, the TVs that we buy today is light LEDs or LED screen, LED screen. What it means is that it has billions of those dots, so that your pictures, each of those dots can assume a particular color of high definition. High definition means that you can zoom, like it can be very, very detailed, and that's why the pictures are clear. So we can down relate to some of these things that are happening, that people use randomly. Okay. Okay, let's move on now. This concept that we kind of outline now shows that when somebody say, okay, give me, transfer a picture through a Bluetooth to me or something like that, you are not actually transferring a picture, right? What you are transferring is bunch of these words, ones and zeros. It will leave a phone and go to the other phone and what? Good. Now it will reassemble in that phone, and this is what we call like file extension. Okay. Now we're going to talk specifically about the file extensions for images. And we're going to talk about how they come about. So for images, they are broadly divided into two. I've mentioned pixels. So when we talk about raster data or bitmap, okay, raster and bitmap, they are the same thing. Now you are referring to pixels, okay? But when you talk about vector, you are referring to um, images that are done through mathematical computation, okay, by curves, paths, and all that. So there are images that are formed by dots, and there are those that are generated by paths and mathematical formulas. So I'm just going to clear you on this, okay? But you need to understand some of these things, okay? It's constrained by resolution and dimensions, right? The other one is infinitely scaled. Infinity scale means if you keep on zooming a picture, you're going to get to the point where things are blurred. It begins to appear like a collection of boxes. That's why raster, that's the bitmap that is measured in pixels. They have constrained by resolution and dimension. I just mentioned resolution. So you can see you have megapixel, all those things. They are resolution. That's why a lot of phones that are coming now are better than the other one, because you have to keep on increasing the resolution as technology improves. Okay, the other one does not. Okay, capable of rich complex color blends. I've talked about color blending in the other one. Okay, difficult to blend color without what rastering. So most of the time, equally combine from one form of picture to another form of picture. The other bitmap or raster has large file size. This one has small file size. So examples. Okay, now I have talked about file extension. Extension is whenever you store a file, it ends with dot something, dot doc, dot pdf, dot. So that's what we refer to. This is not a class for file extension or file system, but I just have to mention it. So most of you will see something like dot jpg. Just know that one. You don't have to go into JPEG. Some people call it JPEG and all that. So this other one have different file extension, PDF dot SVGs. Those that are doing design will understand what I'm talking about. Okay, there are equally software that work on raster data, and there are software that specifically work on vector. Software like Photoshop, okay, work on raster data because that's how you can, edit your picture, because the picture that we upload in Photoshop mostly are bitmap or raster pictures. But things like PowerPoint, Adobe AI, Figma, and all that, okay, they kind of manipulate what Adobe Illustrator, CorelDRAW, and everything. They manipulate vector. But there are some software, of course, that combines both. I think CorelDRAW does a lot of job on that. Even PowerPoint, you can combine a lot. So, then so let's just go on. Okay, what you are seeing on this screen is giving you now a clear example. So you know, okay, this is what they call bitmap. This is what they call vector. Again, another name of bitmap is what raster. So you can see if you zoom the edge of a vector diagram, see it's very straight because that curve is defined by mathematics. If it's a circle, if it's a curve, if it's a rectangle, if it's a block. But if you look at pixel, right, you can see that bitmap you saw there. If you zoom it, you start seeing small blocks. So you see other examples of raster versus vector, okay, to just kind of give you an idea of what this picture. This is another one. You see a raster data, that's a bitmap on the left hand side, then a vector on the right hand side. Now, most of these things can be compressed because we're going to go through why I'm mentioning these things, that when we go to AI, see how the machine actually gets this image, how it's able to generate some of these things because we're going to talk about the generative AI for image. We're going to talk about editing of images and all that. Now, part of the thing that we need to understand is for images, there are two types of compression. When you say, oh, compress this image for me, yeah, sorry, WhatsApp have compressed my image and all that. Okay. There's what they call lossy compression. Lossy, as the name implies, is that you lose some elements while you are compressing. Look at the example that is given here, right? From far, I think that the first and second one, they are the same. They are not the same. The second one has been compressed. Compression simply means that if there are excesses of something, you can remove it. So for this one, you can see that you have red, how many red boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9. The second one, you now have 1, 2, 3, 4, 5, 6. Okay, and so on and so forth. Now, what's this? The idea of compression means that you still have the representation, but you have lost some, elements or components of that particular image. Like now, if I don't tell you, if I remove all those lines in between, the first one is still going to be looking like the second one. So in case you have a software that does compression of pictures, this is actually what happens. Trying as much as possible to remove excesses of stuff so that the component, the pixel will reduce. So when you can compress a picture, some of you have experienced this. You are applying for maybe something and you want to upload a picture. Say no, this website will not accept anything that is more than maybe 10 MB. You don't have to compress it. But when you compress, you see that your passport is still the same thing, but you have lost some. It's not really the same thing. That's what I'm trying to say. You can compress that 20 megabyte down to even 5 kilobyte, 20 kilobytes or 100 kilobytes. It will still be looking the same, but this one is lightweight because it has lost some so that's what they call lossy. But there is a compression called lossless. Lossless compression, you could see all the some of you have seen, some of you have used WinRAR, something like that, or Zip. You understand? So what he happened is using some form of algorithm. You can see if there are 9 reds, okay, it will put like 2 boxes, arrow 9. The other one is what? Y7. The other one is B11, G6, P4, and P. Now you can see it has been compressed, but it has not lost anything. It just stored information in such a way that if I take it to another system, I can regenerate back, okay, the original one because I have the numbers that are there. But in the first one, I cannot regenerate it back. So this is lossless. We have not lost. Just have the name like that. It's very easy to understand. Now, if you're looking at file system, different images. These are some of the images you are going to be dealing with. JPEG, okay. I'm not going to go into this, right? This is beyond your scope. When people come in for their training, I just actually picked up this thing from my diapers training where I break them down. So all you need to know in this class that there are different file formats that you can use to images are represented with. And this thing we are looking at here is what I referred earlier to as file extension. We have JPEG. So this is just their full meaning. Of course, I'm going to share the slide. You can go and read and read. JPEG simply means Joint Photography Expert Group. It's actually, these are standards. PNG means portable network graphic, GIF, TIF, blah, 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 blah. So this is not to go into this, but I am taking you on a journey so that you now understand what we are talking about. Now, if you have all this image, how does AI come in? That is the important question. So there's what they call image processing. Everything you type and block, you are using your AI to generate something is about image processing, right? So what has happened that they've processed a lot of images pre-trained, okay, generative or transformers in such a way that if you ask a question next time, all those billions of pictures that are being used to train, they can try to regenerate it. So in the process of ML, what we have, this does not equally concern because we are not the ones doing the processing, but it's good to just understand and then we move on. At the end of the day, this does not concern us. We are just we are interested in the tools and the application. Now, the inputs, okay, it captures the raw data of the image, choose camera sensors and everything. Then pre-processing is cleaning and enhancing the image, right? If there are noisy part of the image, there's an algorithm that does that. A list of those algorithms are listed but is none of your business. You're not studying machine learning or core data science. So the next thing is segmentation. So after cleaning it, it breaks this thing into segments. Okay. And then each of these segments, it extracts a particular feature. There are a lot of features, colors, textures, and we are going to talk about elements very soon. After extracting the feature, it will it will interpret it and then analyze the features and give you an output, right? So please don't really bother about cramming this thing. This all I'm doing now is to take you through a journey. Now, when you have now is if you have an image now, you pass it through all this thing and then goes through the outputs. This is like visualizing them in such a way that we are now talking about large language model. Okay. Now I am going to relate it to you. Somebody might be asking because in the practical, we are going to be using text to generate images. Okay, we are not going to be designing with Corel Draw or something. So this is what really happens, right? It breaks this thing, it transforms, it takes all these steps in such a way that if somebody puts something like now, you can see I have trained it now. I put it in large language model so that it will generate a text for me. So any day I come out and type in that text, is this burial efficient blah blah blah, it will give me yes. Or if I say give me an image of this, it will use that large language model to generate the image. So that is what we are talking about here. Now, when you are generating image, now we are now narrowing down to tools and applications. You need to take, notes of elements and principles of design. Because the reason why your prompt, because at the end of the day, all these things will end in prompts, because that was why I took my time to talk about prompting. Okay, it's going to end in prompting. What are you prompting? How are you going to be describing your picture so that you can get this thing? You need to understand that there are elements and principles around images, and so that when you are giving your prompts, it will be, somehow very helpful than giving a generative prompt if you don't know the language. And because of that, I think it is good for this class for us to look at the what element of design. What are the elements of design? You need to look at what first the text. You can give a prompt and ask it to put an inscription. And in the inscription, you can tell it to use a particular font style and everything. Some people are hearing this thing for the first time. Yes, there are different types of principles and elements. So we're going to run through them. Number one is text. Number two is line. Then number three is value. You have color, you have shape, you have form, you have space, you have texture. Okay. So let us go through each of them one by one. So when you have the element and principle of design, you are now talking of what art. This is not just pure science. Creativity is an art. I want you to understand that. So let us look at space. Space is an element of design. People don't know that. Okay. The way you handle space will determine if you are going to have a good design or not. Right? So some people can be clumsy with their spaces. Very, very clumsy with their spaces. So some people don't know that there's a way you handle space and the design will not come out well. So if you look at the samples that we have given here, look at the first two, you see that one is giving you a sense of balance. The other one is chaotic. I don't need to tell you, but if you observe very well, if you look below it also, you see another one that is giving you a sense of balance. The other one. So the way you use your space is already giving out information. For those that are doing UI, UX and everything, of course, you understand the whole design principles and stuff like that. So you have negative and positive. So what's happened? What's the difference between the first one and the second one? The first one is showing you like, okay, it's like a cylinder or something like that. Okay. Second one is giving you let me say a holo, because the way it is done in space sends a different message. Okay. Now, you look at this other one, you can see that there's what we call symmetry in the last figure, and the other one there is no symmetry. So now, if you go to this, I want to compare this particular one, right? I want you to look at this particular picture and this one. I want on the message, what's it called? The chat session, choose between, call this one A and call this one B. Okay. Just give me your option. Which one would you prefer? You know, on the chat, please. Oh, I want this thing to be interactive. A, okay. Vetri say A, okay. Adeboy Ega A, Fares A. Thank you very much. So, of course, A. Sophia say B. All right. So, now, some people might be. I think the majority carries the votes, right? So, yeah, this is A, and what? This is B. This is A and this is B. Now B might be, oh, it is, the picture is very clear, it is large. In fact, the fonts are very legible because they have bigger font size and everything. But see, in the principles of design, it doesn't matter. I know having bigger font is okay, but you look at this, right? The difference between this and this is the use of space. Now, there's a way you use space, it will give you a bad design also. So let's just go on. Now, text also is a, now text has different things. It has typeface, which people call font style or typeface, font style. What does that call this thing? There are other this thing. Orientation is equally important. The format, is it bold, is it underline, is it italics? Even the font style itself, okay, the font style can show different things. If I'm doing children something, I might have to use cartoonish fonts to do that rather than very, very serious fonts. Okay, so fonts can equally be used to represent like kind of movement. It can be used to emphasize stuff, can use for simplicity, balance, and all that. So font is there. I mentioned line. Line as well kind of sense some kind of information as well. Look at the first one. First one shows you like nodes. Even though the second one is similar to the first one, but the second one you will notice that is as if these are rods that are crossing each other. So already from this design, you can already see. The other one, what I depicted with it is something that has to do with perception. Okay. Even though this is a 2D design, but you can see it has been turned to 3D, meaning that there is there is a sense of what is on top of the other one. Then going to the two, okay, you could see what we call flow. Okay. Now it gives you, okay, some are closer to each other. It means those ones that are closer are farther away. So even line can be used to represent, perspective. Okay. So another one is shape. Okay, shape. Um, what you've noticed is that even line and shapes, right? You can use it as either organic or geometric. So what you are seeing here, you are seeing organic and geometric. Geometric is something that can be defined by mathematical formula, just like we're talking about raster data. So, but organic, you see the organic there. You can see the bottom right. Okay. So for shapes, you can either have the fill, okay, two, or the outline. So these are elements that you can actually use to depict shape. Then color. All I need to mention here is that there's what they call color palettes. So when you are generating your image, you can equally give it like a color palette to use. Pattern is simply things that are repeated. Okay. It could be a line that is repeated, it could be a shape that is repeated. Now, for pattern, you can equally have what we call geometric pattern, which is on the left hand side, and organic pattern. So when we talk about organic pattern, it kind of gives you a sense of nature, right? Geometric gives you a sense of mathematical formula, but organic gives you a sense of nature. So you can see in line, in shapes, and in pattern. Now, texture gives you a sense of the material that is being used. So, for instance, gold is a material, metallic is a material. For wood, you use mostly brown. For marble, you use ash and everything. So all these things are part and elements of design. So rounding off, I'm not going to go. All these things I'm mentioning, there are a full lecture on element of design, but I just have to mention them in passing, okay, so that we will understand. So what we call design element matrix, where you can combine the element and some of the principles. Line with balance, movement, pattern, contrast, rhythm, and this thing. So when you are trying to generate an image using AI, please try and see if you can depict a pattern, a contrast, a rhythm, a unity, a shape, a form, and something like that. Okay, when you do that, you can master, this act better than someone else that just jumped into it in this too. So let this our theoretical aspect of it not be in vain. Okay, now we are now moving to the AI tools. Okay, there are AI tools we are going to talk about today. Of course, this is part one. We are going to come back, with other parts. So we are going to focus on image generation tools today. There are other image editing tools using AI. There are AI image analysis tools and stuff like that. For image generating tools, they simply create image from text prompts. Simple. That's where we are going to start today. We have, tools like Meta AI. I'm going to either use Meta or WhatsApp is Meta, by the way. So I think I have WhatsApp here. I can use WhatsApp. You have Mid Journey, you have OpenAI DAO.e, you have Stable Diffusion and Adobe Firefly. These are the most common ones. Again, if you are waiting for Lawrence to teach you all the image tools, you are joking. It's not possible. Okay. But by the time I've given you the principles and then we do some examples, the world is yours to explore. What is the use case for illustration, for product mockups, for artistic concepts, and for storytelling visuals? Right? Now we have other tools like AI image editing tools. These tools enhance the retouch. Of course, the image is already existing. That's the difference here. Okay, Photoshop now have what the word generative feel. In fact, Photoshop has a full AI package, right? For those that used to use Photoshop, it is even easier to use Photoshop today. Of course, our almighty Canva. Canva is the most popular cloud-based design. Okay, even though Canva AI Studio is simply what is trying to do now is it's like an enhanced search. If you can use, do you know you can use Canva um to what was the last class? GPT, yeah. You actually have to configure your GPT. See, we are going to merge all these things together at the end of the day, sha. So you have photo AI editor, Lumina, Neo AI. The other ones like Da Vinci and all that. But you cannot in this class, handle all of them. So sometimes it removes background, object removal, color correction. So you're going to see these things, how you can remove color background, optical character recognition, and stuff like that. Then the last one is AI image analysis tool. So yeah, you can generate, you can edit, or you can simply describe an image. I don't know any other thing you can do with image. These are the three major things that will do with images. Okay. So yeah, somebody say, wow, yes, that's possible. Yeah, there are a lot of things people guys don't know about this AI. So this class is to let you know what you can do with it. The tools identify objects, face, text, pattern recognition. So when you say put your face, let this door open, you are not either generating an image or editing an image. Facial recognition is used to open doors, all those kind of things. Computer vision. So when you talk about computer vision, I'm going to look at that one. Chidinka Daniel, don't worry. This this is part one. Okay, this is part one. Don't be faster than you. But also curiosity can lead you to even go ahead of me. I don't have, what's it called? I don't have the gates to protect knowledge. Knowledge is a free flow in this era. Okay. So we have another one like vision clarifier, and then the use cases are facial recognition, image classification, text extraction, safety detection. You can even use for checking whether something is wrong. But capture is using a lot of all these things because he knows that it is preventing, discrete computer vision by a robot. So it's only a human being that can do some of those verifications. So you can see that some of these things are applied. So let's talk about AI image generation tools. Of course, at the end of the day, what is sitting between us and this is what we call what prompting. Okay, prompting. You can see that we need to. Next class, we are going to do prompting for images, especially, because it needs a fresh head, right? So how you interact with this thing is prompting, and we have a lot of them. This is not exhaustive, ladies and gentlemen, and there's no way Lawrence can even cover all of them. So we are going to do some form of, you know, let's see if you have enough time. Yeah, you have enough time to pull up and do some things. Okay. So yeah, we have Meta AI, Leonardo.ai, Imagine, Adobe Firefly, Flux, Midjourney, Stable Diffusion. That so again, I don't want you people to be overwhelmed, right? If you can select any of these, that's why I did a session where you have to compare and contrast different, large language models. There are a lot of them. So the same way, don't kill yourself. I don't know. See, if you learn one very, very well, um, yeah, okay, Gemini image, yeah, it's true. Of course, I say it's not exhaustive. Okay, yeah, it has. There are gems, self. There are. See, guys, this whole AI thing is kind of exploding. Okay, people are even designing their own gems and their own. What I mean by gem is equivalent of custom GPT in Gemini, right? So if you go now, go to even ChatGPT and say image generation, what's it called? Image generation, custom GPTs. You see, there are a lot of them. ChatGPT itself also is image generation, this thing. So imagine again, this is, there's a lot. There are different kinds of image. What if I want to, if I want to, what example can I give now with image? Imagine I'm a medical doctor and I want to specialize in X-ray. Okay, I can get my file of X-ray diagrams. Okay, and pre-train it like we did in the other one. I can generate my own custom GPT for my own hospital, and I can share it with my colleagues. And it's not a way that once you get a what's it called, like an X-ray document, I just put the image there, and it will just give me everything I need to know, whether the bone is broken and everything. Yes, we can train it with like with that. You can see that ChatGPT might not be able to do that, but for my hospital, we have real information that cannot be found anywhere, and we can make such make this thing. So you could see these are use cases. There's a lot you can do with it. Okay, there's a lot you can do with it. So think Lawrence does not have all the information. So think bigger how we can make use of this. Okay. So today we're just going to look at the issue of them. Then when we come back, we can drill deep down into this. I don't usually like putting everything in one lecture. I like taking it piecemeal so that next time it's all going to be about image, image, image. If we are going to touch Gemini and all those things, okay, that will be, oh, today is Thursday, that will be next week, Tuesday, okay. So I'm going to stop sharing now. Okay, so this is the kind of thing you could use. Now, you can see some of this. Okay, it's prompt that I use to generate all these things. Prompts. You can see how real they look. Okay, some of them are not really very good. Okay, some of them are not really very good. So, some guys, if you don't, this is WhatsApp. Oh, everybody, I'm sure all of you in this call has WhatsApp. What are you using your WhatsApp to do? To gossip and go and quarrel in a group or something like that. This is WhatsApp. Like I said, you don't have to really learn all the AI tools. This is me. Like there is nothing like these are things I did myself. There's nothing. I believe my WhatsApp is not generating image. Oh. Yeah, who told you? iPhone, Michael. Okay, iPhone. I don't know. It is there. Who they talk that one because you never try them. It's there. It's there. Okay. Even this thing that I see here, you know, I kind of put some of this thing. It generates images. Yes. All these things you are seeing here. I'm glad that some of you, are getting to hear this for the first time. Look at very complex images. Somebody is asking how do you remove meta? I know now. You cannot be. You have to go for paid version. You have to go for paid version. All right. So where do we start from? Okay. You keep on trying. You can see some of these images are not very well. Some of them you might discover that somebody's leg. I want to find one that the person's leg. You can see Christmas is coming. I can do my own and wish my parents. So all these things, just try it out. So do you generate images in WhatsApp or for convenience sake, or there are different between images? Now, use convenience. I use WhatsApp here. Yeah, let me answer your question directly. Convenience. Before I go and open ChatGPT, WhatsApp, I normally chat and I generate, and you can see how clean the image can be, right? So this you can see there is nothing I have not done with this. There's nothing. So I know that I am now all powerful. AI has given me to, okay. I have built a lot of flyers. I've designed a lot of flyers for people. This area now you are looking at now. What I collected for this project is 1.5 million because someone wanted to transform info. He gave me a raw data and say he wants me to do a PowerPoint slide for it. I say, oh wow. I say that it's going to be very difficult to, this thing. You have to somehow, you know, um, convey the message that it will require some work for it to come up with the design. And the man said, oh, I told him 2 million. The man beg, beg, beg. So what happened is that he had a plain document. He wanted to develop a video for each of those documents. And then, so he gave me 6 documents. Guess what I did? I told her, sir, this is going to be very long now. He need to break the documents to 5 video series. So what I did was I used one document again using AI to break it into. I say, use this document, break this into lectures that will take 5 episodes. This is text. It happened. After then, I now started generating um I now started generating slides for each of them, and then we did like a voiceover and then deliver the lecture. So how did I make the money? I made the money by telling the man that you are going to do 6 of them. Each of them will be broken down to five videos. 6 times 5 is I think is 30. 5 times 30. That's all, guy. You know what it means to generate 30 videos and all that, man. I'll not gonna lie you. We did that in 3 days and we delivered it. All thanks to Open AI. I took my 1.5 million and went home. Martha, your hand is up. You want to ask a question? Yeah, negotiating skill, Fares. My brother, you need it to hug is real.
Yes, sir. Good evening, sir.
Yeah, good evening.
Sir,
Ask your question.
some of these things they require like the paid version. Like the
Some of
assignments you
which
gave us.
is okay. Sorry.
Yeah.
Are you referring to the assignment? Are you referring to the image?
Yeah, like you said we to remove the Meta logo, you need the paid version. And even the assignment you gave us to like build a custom GPT, I
I
it
did not
requires
give
the
assignment to build a custom GPT. I've corrected this in the last time. I said
okay.
generate a like I will still give, not what I'm saying, I'm still trying to figure out how I will do that. That's what is delaying that process. What I said is I think is the 8th class that we did, where I taught strategy. Because in this lesson, I don't just want to teach people, you understand? So if you need to have a strategy, so I told people just take one of the thing in the group. That's why I said from the beginning of the lecture, I said some of these assignments will be tailored to what you are doing. So I want you to kind of trigger that curiosity. For instance, this is from our accountant, you understand? And you think about what custom GPT can probably, if I am working in a team and I want to develop it for my department, right? This is just an example. Okay, you don't just jump into it. So what I thought first, because I can equally go straight and teach custom GPT. Blah, 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 blah. So what I thought first was like, okay, somehow, if you are serious about that particular project, you need to take time and plan it. So the last assignment I gave, okay, the last assignment I gave was how do you, okay, strategize on how to develop this thing so that you know what you need, okay? Do you need audios? Do you need videos? Do you need links? Do you need PDF? Where do you get them? So that you understand that this whole thing is a business as well. You can become an AI entrepreneur, right? You can become an AI entrepreneur. Like I said in the last class, I've even made some money, just suggesting to a guy that works with NNPC that he can do something for a department. I just gave him an idea. The guy said, wow, this will solve a lot of problems. Because there are some of their documents that are not online. And those documents are what they are using in their office. So I gave him this idea. I said, wow, do you know that? I say, yes, if you do that, you can even tell it to do some calculation based on the formulas that you don't need to go. It will go inside, bring the formula, calculate the whole thing, and give you the answer. It will think based on the information. You are pre-training it, pre-trained transformer. The guy didn't know that this was possible. And as I'm talking to you now, he is paying me consultancy fee just for bringing that idea. This one I'm showing you now, I did not joke, 1.5, 3 days, I'm done. 3 days, I'm done. I can even show you the files. I don't want to I can show you the files. I even use some um logo, what do they call it? Logo, there's something logo revealing, like logo will come out, and I did all those things now. So for this particular WhatsApp, I'll answer you directly. I did not pay. And I don't have to, if you see Meta AI, come and arrest me now. Because there are ethics involved in this AI as well. I cannot use this image and say and claim it is mine. Okay, that was why you remember there was a time I told you people to choose images from the one I generated. All the AI, sorry, Meta AI is there. But it is showing you the possibility. Imagine if I really want to go into business. See, if I see somebody that pay me another like 2 million, that me, I will pay. Oh. How much is Meta AI that I cannot pay? I'll pay. Because I am now using it for business. So I'm equally encouraging some of you, okay, go to the next level, okay, and somebody say show us the road. I don't know, but how can I show you? Okay, now, okay, use this last example that I gave. Okay, the guy did not call me for consultancy. I am the one that told him, okay, this is how the conversation started. He was talking about, we're just talking about AI. Again, I was the one that introduced the topic of AI, which means I have to take the credit for even bringing it up in the first place. So we are talking. Say, oh, he has used it for this, used it for that. I was telling him that I'm taking a class on AI. I say, yeah, yeah. He felt that he was feeling good about himself, telling me all the things he has used it for. I was waiting for him to learn because I know that there are things he have not even used it for. So I told him, sir, what does your department to do? So, Martha, I'm giving you sometimes you introduce the topic and tell the person, do you know that you can do this and this and this? Now, let me tell you something that happened in Code House recently. We have one of our students that was graduating, he brought about one idea. And I transmitted that idea into something else. I'm not even going to hide it from anybody. I told you know that you can have an AI that can generate question based on any topic at all. Do you know that I can take this my recording, all this my video I'm putting on YouTube, and set maybe um I can set hundreds multi-choice questions. Let me even be showing you certain things. I can meet a lecturer and say, you are still setting your question, mother. No, no, no. There's a way I can help you do that. It will even mark it and give you the scores and even put it in Excel. You say, wow, what? I will go to the person that does agentic AI. I say, how can we do this thing? Remember, people are learning this. When we are coming to the end of there's going to be like a merger. Okay, we're going to do some project where you can interface with those that are learning agentic AI and those that are learning AI for developers and everything. So that, guys, I want us in this particular cohort, let us bring out 10 Obonge products that can sell. So I'm showing you the way now. Let us think outside the box. This is not about teaching. No, there's a way. We are a community. In fact, we are a force to reckon with now. Just this class alone, with what everything I have taught, I have opened some people's like possibilities. Let me just name it. To begin to think outside the box, something things that they can do and all that. So imagine other people that are learning other things. Here. Code House, meanwhile, to just mention, Code House is going to be celebrating 10th anniversary next year. And we are moving into becoming an AI-centric company. And there's no way we can do it without, kind of opening our arms to people doing free training and all that so that people can, we are just like tour guides, right? Please follow us. And I like the idea of show me the road because that's what I'm doing. So at the end of the day, can we boast of, right? 10, because it's 10th anniversary, 10 serious projects, like crazy. I tested you guys with crazy ideas. Some people chickened out. But that's for me. I'm not just doing this thing for doing sake and all that. So we are going to, this is already 8:27. Next week, we are going to jump into all these things. I'm going to show you how I did all some of these things. We need to really drill down and get it done. It's going to keep on getting interesting. This is just the beginning. At the end of the day, of course, we don't need to code. We don't need to do mathematics or this thing. All we are here for is to discover what it can do and what we can make it do. Emole, at this point, I think we are done with the class.